Hello everyone, welcome to a presentation on designing a scalable data warehouse in the cloud for real-time analytics. We are TeamX, Prashan, Ayush, Avinash and I, Asit from IIT-Jodhpur. In this talk, we'll walk you through how modern cloud services can be used to solve challenges of real-time analytics and build a scalable, efficient and future-ready data-driven warehouse. In today's data-driven world, businesses need quick insights to stay competitive, but in traditional on-premises data warehouses faces many challenges. They are built for batch processing, not real time. They struggle to scale, especially with the massive volume and velocity of the data from IoT devices, messages, and web pages. As you can see on the presentation, there are a lot of challenges with the uh, data that people generally faces like static workload handling, scaling process, high volume, legacy data warehousing, and there's a lot of things. As a result, businesses are using these days system experience delays, can't react in real time, and often misses key opportunities. That's why modern solutions are shifting towards the cloud. And we have done the project designing a scalable data warehouse in the cloud for real-time analytics, where we have built a scalable data warehouse in Azure. For real-time analytics involves using services like Azure, Databricks, Data Factory, Data Lake, SQL, and Power BI to process and analyze the data. So Avinash has done the research part. So I request Avinash to explain the literature reference part.
Hello everyone, my name is Avinash Singh. In this project, I work on literature reference and architecture diagram. To understand the best practices for cloud-based data warehousing, we review several paper and industry studies. A few key insights stood out. First, combining real-time and historical data helps generate deeper and contextual insight. Second, well-defined schema and data quality check are crucial for trustworthy analytics. And third, scalability and flexibility and cloud-native service are a must. However, most of paper lack practical implementation step or were biased toward a specific cloud vendor. Our work fills that gap by building a full pipeline on Azure. We look at how current cloud platforms perform. Databricks achieved record setting speed in TPS-DS benchmark 2.7 over Snowflake. Azure Synapse run 30 TB workload 67% faster and 23% cheaper than Amazon Redshift. Single store so 2-second ingestion and sub-second query even with thousands of users. Rockside maintain 1 to second latency even while ingesting a billion of event in 24 hours. Science of industry found that 80% of companies using a real-time analytics increase revenue by up to 20%. So clearly, cloud-based real-time analytics, and it's both technically powerful and impactful for business. Again, we have changed the architecture diagram in which Prashan work of architecture diagram. For providing detailed summary, now Prashan take lead on clearly define the architecture diagram.
Sure. Thanks, Avinash. So, like as per our research and like we have used Azure services, and on top of that, we are using Databricks. So as you can see, like we have used uh, like uh, like Event Hub and Stream Analytics for ingestion of the data. Data source here will be our like historical data which we got from Microsoft, that is like COVID and CO2 emission data. And for the real time data, we are using like all the Event Hub and Stream Analytics. And Data Factory we are using for doing our ETL jobs, and also to transform the data which we got as a uh, which we got and in the bronze layer of the data lake. So data factory transform that data, and it is putting that data to the silver layer of the data lake. And Databricks is taking that data and it is performing like doing the all the process. Our team member Ayush has written a code for this, and like he has and we have like done all the processing of on the silver layer data, and it is processed to the golden layer. So, and whatever the process data we got, we have created a Power BI presentation on top of it, like dashboard. So, let me share the Power BI dashboard, like one of the dashboard which we have prepared. So, you can see this dashboard. This dashboard talks about uh, about each country, like on each year, how much COVID vaccine they have taken. So this is one of the sample dashboard which we have created. There are multiple which dashboard which we have created for this purpose. And now handing over to Ayush.
Yeah. So, like as Prashant explained, in like we had users of multiple services of Azure. So this is our resource group in which we had deployed multiple services of Azure. So as you can see here, we had four different storage account here, one event hub here, and one data factory and one Databricks service over here. So the uses of four different storage account here is that, like, once we are getting the raw data from the event hub, we are storing it into our raw data layer. After that, like we are loading it into the bronze layer and then processing to the silver and further it to the gold. So for each layer, we have a respective storage account, and we are loading our respective layer table into that storage account. Uh, Now going to the Databricks code. So in the code part, firstly, what we are doing is, like, we are using PySpark over here, and we are importing all the required libraries from the PySpark into this notebook initially. After that, we are using since we have to connect to the four different storage account here, so we are establishing a connection with four different storage account here with this access key. And the reason why we don't have this access key within a scope over here, since we are using the trial version of a Databricks account, we are keeping it the access key directly over here instead of keeping it in the scope. So after once we had the connection established, we are using the dbutils command to verify whether we are able to connect to the storage account properly or not. After that, I had a few functions which I have created over here: clean column name and clean df column. So these function we will utilize in order to do the cleanup on the column names which we are getting in the CSV file name. The reason why we are doing this cleanup on the column name, because when we create a delta table doesn't accept any special character or any other character apart from alphabetic and numeric as in a column name. So that's why we, in order to automate that part, we created those function to clean up those column names. After that, once we had those cleanup, we had some global parameters which we are passing. So in these global parameters, we are doing nothing but we are just passing the path of the individual layer for each data file, the respective data file. So as you can see over here, we had a raw file path, bronze layer path, silver layer path, and a gold layer path. After that, we had a data quality check function. So in the data quality check function, what we are doing is we are trying to identify any missing column if we have any in the CSV file. We are trying to do the count operation just to identify the data frame is not empty. And after that, we are also checking we have all the required column into our data frame or not, or the CSV or not. And once all these quality checks will be passed, then only we will be processing our raw data to a bronze layer, and we will be writing that data to a bronze layer table. So in order to, yeah, so as you can see over here in the result section, we all the quality checks has been passed, and after that the bronze layer has been written as a delta table into that specified location. Okay, so as you can see, the multiple checks has been done, and accordingly, all the quality check has been passed, and the date and the bronze layer has been created successfully. After that, we come to the silver layer. So silver layer has been created once the bronze layer has been completed. So after that we read it from the bronze layer, and then we do the, on top of that we are doing some set of transformation on a silver layer. So in the silver layer we are doing nothing but we are doing some renaming of the column names, as well as we are doing some data type casting over here in order to provide the correct data type for further processing of the data. And also along with that we are also adding some new column based on some filtering and case statements. So based on that, like one of the column which we had created over here is emission category, which is been dependent on the case when statement. So based on those cases, it will assign how much level of emission is there. So similarly, in the vaccination data also, we had a same set of transformation over here, in which we are doing some casting over here and renaming of the column, and some new columns has been populated based on some cases and conditions. Okay, so once the all those transformation is being done, we will be writing our silver layer table, and as you can see on the screen, the silver layer tables will look something like this. Okay, come going down to the golden layer. So once our silver layer will be prepared, we will come to the gold layer table. So before creating a gold layer table, we will be reading the data from the silver layer, and after that we will be doing some aggregation, which will totally depends on the use cases uh, to which we are presenting on our dashboard. So there are few aggregations which is been done based based on the graphical representation which we wanted to show. So one of the example over here which we took is like we wanted to present how much vaccination is been done in a particular country in a particular year. So based on that, we did some aggregation in order to get the count of the vaccination is been done in the particular country in a particular year, and that is been displayed in the Power BI dashboard also. So this is our code part. And coming to the orchestration of this notebook, so in order to do the orchestration of this notebook, we created one pipeline on the data factory. So we use the Databricks notebook activity over here in order to create this pipeline. So in this pipeline, we created a link service with the Databricks, and we use the token we use the Databricks token in order to access this notebook, and we are using a all-purpose cluster, existing interactive, or you can say existing interactive cluster to run this notebook. So we created this pipeline in order to automate this notebook and create a trigger for this notebook so that this notebook can run in a automated weekly or in a hourly manner. So yeah, that's all from my end.
So just coming to the next part of that. So now we have got the real sites, and we had also done the comparison between various cloud services and things. So like our solutions are always best because we are using that. So just coming to the conclusion part, uh, especially cloud-based architecture are on Azure offers the scalability, flexibility, and performance required for the modern analytics. Real-time data is no longer optional, now it's necessity. By combining Azure services in the Lakehouse architecture, we can simplify data workflows and unlock real-time insights at a scale. Now coming to the future part, like the future of the cloud, like we can say the future scope. So it's already a present and now it's also a future. Integrate ML modules using Databricks for predictive insights. Use data live tables for advanced streaming ETL. Expand to multi-cloud or hybrid cloud deployments. Further reduce latency with the newer Azure optimization. So the newer updates will definitely help us. So thank you so much everyone for your time and patiently listening the same. I'm thankful for my team members Prashant bhai, Ayush bhai and Avinash for the guidance, and also I'm thankful for Professor for helping us. Thank you, everyone.
Thanks, everyone.